All right, we are on a roll. We're still looking at recursively defined sequences, and now we are going to write an explicit rule for each recursive rule. All right, so here's something to help. An explicit rule for an arithmetic sequence. A sub n equals your first term plus n minus 1 times d. All right, so if we're trying to write an explicit rule, you need to know what that's supposed to look like. So here's what that's supposed to look like. All right, let's get started. All right, so A part says A sub 1, my first term is 25. I have A sub n equals my first term minus 10. So I know that my common difference there is negative 10. My first term is 25. So the first thing I'm going to do is go ahead and write down my formula. All right, now I'm going to fill in everything that I have. So I've got A sub n. I know my first term is 25. And I've got, that's going to be plus n minus 1. And that's going to be times my common difference. My common difference is negative 10. All right, so I've got A sub n equals 25. I've got negative 10 times n minus 1. So I can use distributive property and say minus 10n. N times negative 10 is minus 10n. And then negative 1 times negative 10 is plus 10. All right, now I can combine like terms. So I'm going to have A sub n. Oh, I forgot my n term. All right, I was saying it, but I didn't write it down. So I should have negative 10n and then plus 10. All right, so again, I was doing distributive property, n times negative 10. Negative 1 times negative 10 is plus 10. Now combine like terms. 25 plus 10 is 35 minus 10n. If I want to rewrite this in slope-intercept form, I could change this around and I could have A sub n equals negative 10n plus 35. All right, and that would be an explicit rule for part A. All right, we can see that B part gives us our first term is 19.6, and then it tells us A sub n equals negative 0.5 times A to the n minus 1. So I can tell this is going to be a geometric. All right, so an explicit rule for a geometric sequence. Let's go ahead and write that down. All right, so now I have my first term. So I'm going to have A sub n. My first term is 19.6. And then I'm going to have that times my common ratio. My common ratio is in this part of the equation here, so negative 0.05. And that's going to be raised to the n minus 1 power. Now, there's nothing to really be simplified here because, again, you have to do order of operations. You would have to do a power before you could multiply, so you cannot multiply these together. So when you get to here, you can say the explicit rule is A sub n equals 19.6 times negative 0.05 raised to the n minus 1 power. All right, now example 4, we're going to do just the opposite. We're going to go from explicit rules to a recursive rule. All right, so it says write a recursive rule for each explicit rule. All right, so A part gives us A sub n equals negative 2n plus 3. We can tell that this is arithmetic. And if we want to find our first term, we're going to say a sub 1 equals negative 2 times 1 plus 3. Negative 2 plus 3 is 1. So our first term is 1. So a sub 1 equals 1. So now we have our first term. And then we have to know the formula. So again, the formula is a sub n equals our previous term plus our common difference. All right, so our common difference is going to be negative 2. And so we just have to write all of this together now. So remember, the first term is part of it. You can't forget the first term. So a sub 1 is 1. Our first term is 1. And then a sub n equals our previous term plus our common difference. And since our common difference is negative, we can put minus 2 instead of plus 2. All right, so B part is exponential. We can see that it's exponential, so that means it's going to be a geometric. So we're going to say a sub n equals negative 3 times 2 raised to the n minus 1 power. So we can say that our first term, again, just like before, we can say let a sub 1, I'm going to plug in 1, so I'm going to have negative 3 times 2. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times negative 3 is negative 3. So our first term is negative 3. Then again, we have to know the formula. So we're going to have a sub n equals our ratio times our first term, our previous term. All right, so if we want to put all of this together, we know that our common ratio is 2. So we're going to have a sub n equals 2 times a to the n minus 1. All right, so for a recursive rule, again, you always have to have your first term. We found the first term up here, so a1 equals negative 3. And bring down the rest of a sub n equals 2 times a to the n minus 1, or our previous term. So there you go. That is how you go from explicit to recursive, and then back from recursive to explicit. Example 5, Fibonacci sequence. All right, this says use the sequence shown. So we've got 1, 1, 2, 3, 5, 8. So it says write a recursive rule for the sequence. Write the next 3 terms of the sequence. All right, so this is a famous sequence. You can see it naturally occurring in many objects, even in flowers. So Fibonacci sequence, if you get bored sometime, look it up. Lots of cool stuff you can find about Fibonacci. All right, so we can quickly see that this is not arithmetic. It's also not geometric, but it says to write a recursive rule for the sequence. So what is the pattern? We need to see, what do we notice? So 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 5 is 8. So it looks like you're adding the 2 previous terms in order to get to the next term. So if I say a plus 1 plus a plus 2, okay, my first term is 1. My second term is 1, and that equals 2. All right, let's see what the second term plus the third term looks like. All right, the second term is a 1. The third term is a 2, and that equals 3. And that does equal your next term. All right, so let's see. What does A3 and A4 4. So what's our third and our fourth term look like? All right, our third term is 2, and our fourth term is 3. 2 plus 3 is 5. So we have determined a pattern. We can say our fourth term plus our fifth term. Our fourth term is going to be 3. Fifth term is 5. 3 plus 5 is 8. So we can see that that is where our sequence is coming from. All right, so if we want to write a rule for that, how would we do that? All right, so we have to know our first term. We also, in this case, need to know our second term because our first and second term seems to be, well, don't seem to be, it is repeated. So our first term is 1. Our second term is also 1. All right, so instead of just defining the first term, we're going to go ahead and define both of the first two terms since they're the same. All right, so we really have to start with the third term because with the third term, that's when we really kind of start noticing the pattern here. All right, so each term is the sum of the two previous terms. So we can say a sub n equals a sub n minus 2 plus a sub n minus 1. All right, so that's our previous two terms added together. All right, so all we have to do is put all of this together, and that would be our rule. All right, I hope I didn't go through that too quickly. Hopefully you can see that it's just adding the previous two terms together. So if I want to use this, I can say 5 plus 8 would be my next one. So I'm going to say 5 plus 8 equals 13. And then I'm going to do 8 plus 13 is 21. 13 plus 21 equals 34. All right, so all I kind of did was put the numbers in here. But if you want to look at the formula and see exactly what I did, we can say that our seventh term, and that should say a to the 7th. Let me fix that. One day I'm going to be an expert at writing on this, but I don't think it's going to be today. All right, so I've got a sub 7. Still doesn't look any better. All right, I'm going to try that one more time. There we go. All right, so a sub 7 equals 5 plus 8. So what did I do? So when I have a 7 here, I'm going to do 7 minus 2, which is 5. So that means my fifth term. And then n minus 1, 7 minus 1 is 6, my sixth term. So my fifth term and my sixth term added together equals 13. And then for the next one, this would be 8, a sub 8. So 8 minus 2 is 6. So my sixth term plus my seventh term, n minus 1 would be 7. And that gives you 21. And so this would be my ninth term. And you could continue using this formula here to find any number of terms in the Fibonacci sequence. All you have to do is add the previous two terms to get to the next term. All right, if you have any questions, please let me know.